Hello friends, welcome to our YouTube learning channel Accurate ASME ISO. In this video, let us learn geometric dimensioning and tolerancing profile tolerances. Let us learn on symbols, controls and their applications. Please do not forget to subscribe this channel and share it with your friends. Let us begin now. Profile tolerances. This is the symbol of a profile tolerance, and the value 0.08 given is the specification of tolerance given in the drawing. We would understand here what is the profile tolerance, what is called true profile, and we will understand certain applications like coplanarity used in the profile tolerances. Definitions of the profile controls. Profile tolerances are used to define a tolerance zone to control forms independently or the combinations of size, form, orientation and location. If a profile control is applied, either it controls independently as a form tolerance, or if it is applied with the datum, then it controls everything including size, form, orientation and location of the feature, and it is with respect to or relative to a true profile. What is true profile? The true profile must be defined by a digital data file. Here the meaning of digital data file means it is a CAD file. The CAD file comes in the format such as IGS or STEP, or it can be appropriately shown on a view on a drawing. In this drawing, the true profile is this one shown by a red line. Let us discuss now the application of a profile. In this drawing, a profile tolerance is given for two surfaces, 2 into, then a tolerance frame. It means profile of two surface is given within a tolerance 0.08. A profile of a surface tolerance may be used to control the mutual orientation. It means this is one surface and is another. These two must be mutually parallel to each other within a certain amount, and location of two or more surfaces. Also, as they are oriented each other within this 0.08, also they positioned or located within 0.08. So applying the profile tolerance, both the surfaces are oriented and located within 0.08. For example, this is a actual surface. This is a tolerance zone line or plane. This is parallel plane of tolerance zone of 0.8. So these two surfaces must be within tolerance zone of 0.8. Each surface shall be within two parallel planes 0.08 apart. The important is that since these are in one tolerance zone, it is called coplanar surfaces. It is like a control provided a flatness tolerance applied to a single plane surface. Profile tolerances with or without datum. In the last slide, we already learned the profile tolerance applied without a datum. In these slides, we would learn the profile tolerances applied with respect to datums. Depending on the design requirements or the application, profile tolerance zone may or may not be related to datum. In this drawing, a tolerance of profile applied to these two surfaces within 0.08 and with a datum A and datum B. A dash B is called as a common datum. In this drawing, two designated surfaces, this is the surface number 1 and this is the surface number 2. Designated surfaces shall be within two parallel planes. These two surfaces must be within two parallel planes and that parallel plane zone is 0.08. And these two surfaces, the tolerance zone is equally disposed about datum plane A and B. So, the tolerance zone is equally distributed from A and B plane. So, let us understand with this. For example, these are datum A and datum B, simulators. Okay. So, making a common plane between A and B, A dash B called as a common datum or datum plane AB as simple. Now, these two planes first of all must be within 0.04 as 2 into profile tolerance 0.04 is given for this datum A and datum B. So, as we studied in last slides, these two datum plane itself are coplanar within 0.04. Okay. Then now from this datum plane, the tolerance zone of 0.08 for these two planes is equally distributed in both sides, plus and minus, and the actual surfaces of this and this should be within 0.08 from datum A dash B. So, this is datum A dash B, this is the total tolerance zone 0.08 and both the surfaces are well within the tolerance zones. There are various types of the tolerance zones. One of them is bilateral tolerance zone. Bilateral means the tolerance zone is equally distributed both sides from the nominal. This is like this. Now, this is datum A, as the feature control frame shows profile tolerance zone with respect to datum A. So, this is a produced datum plane A. Now, the true profile or nominal profile. The true or the nominal profile is a profile digitally available in a CAD model, or it is to be shown on a proper drawing. Okay. Then 0.8 is the tolerance which need to be distributed on both sides along the nominal surface or the true profile. So, this is total value is 0.8 equally disposed, 0.4 each side, and suppose the actual profile is produced. It means this actual profile must lie within this 0.8 tolerance zone. Now, let us discuss unilateral tolerance zone. Unilateral means the tolerance zone either above of the nominal profile or below of the nominal profile. The indication reads like this: profile 0.8 and there is a modifier called unequally disposed. So, what is the meaning of this? Let us understand through this diagram. This is datum plane A, and here is the nominal or true profile. Now, when we say it is unequally disposed, so unequally in sense it is either on top side or the bottom side, that after this symbol value is given indicates it. Now here the value is 0. So on the positive side it is completely zero tolerance, and below the material or below true profile the complete tolerance zone 0.8 is remained. Now the actual tolerance or actual profile must lie within this tolerance zone 0.8, and this is what it is called unequally disposed tolerance zone. Unilateral tolerance zone can either be any side of the true profile. This is the case where the tolerance zone is completely on the positive side of a true profile. The tolerance indicator read as surface profile 0.8 unequally disposed, and the further value given is 0.8 with respect to datum A. Let us see the graphical representation of the indicator. This is datum A, and here is a true profile. Now in the last case, what we understood, after the modifier unequally disposed, it was a 0. So the positive side tolerance was 0. Now here the total tolerance given is 0.8, and unequally disposed symbol after 0.8 is given. It means the positive side there is a complete tolerance zone, and there is no tolerance zone at negative side. So this is the unilateral tolerance zone, which indicates it is on positive side, and of course the actual profile must lie within the given tolerance zone as specified. This is a very typical case of a bilateral tolerance zone. We already knew bilateral tolerance zone means the tolerance is on both the side of the nominal. The indicator shows here the surface profile controls within 0.8 tolerance, that is the total tolerance value, and unequally disposed. So unequally disposed is given the value 0.2. So the graphical representation explains us this is datum plane as usual, and this is a nominal profile. In all last cases we understood after the unequally disposed symbol u, when there is a value and it is a positive 0.2, then the tolerance is become 0.2 on the positive side or the above the material side. So it is 0.2 tolerance zone. Then total tolerance is 0.8. So automatically with a simple subtraction 0.6 is the tolerance zone below the material or the negative side. So the total tolerance zone is 0.8, above the material or the nominal or the true profile is 0.2, and below the material or the negative side it is 0.6. It is how it is represented. Let us discuss now few more the modifiers used in profile tolerances. Some of the times, looking at this drawing, the profile tolerance is applied at certain area of the part, or it can be applied to the full of the cross section. So there are two symbols is the specifications. To control all around, the symbol is the circle as shown here, and there is one more symbol when it is applied to the entire surface, and that is called all over. When a profile tolerance applies all around the true profile of the designated feature of the part in the view in which it is specified Please be note here that in this view, if it is applied all around, so the profile shown in this view, it is control all around, okay, and it is shown with a leader line. When there is a requirement of the tolerance applies all over the part, okay, so at that time the all over symbol is used. That is discussed in the later slide. When we apply a modifier all around or all over, then the surfaces all around the part outline. Here is a outline, the complete closed profile. This profile shall be within two parallel boundaries 0.6 apart. That means the given tolerance is 0.6, and that tolerance zone must be perpendicular to the datum plane A, and that is equally disposed about the true profile. Here is one example in an enlarged view of this small portion. These two lines are uniformly distributed. When 0.6 is given, this uniform distribution is equally disposed as a bilateral from the true profile, and the actual profile must lie between this uniform tolerance zone. So this is the term called uniform tolerance zone. Here is all over specification. The symbol shown is all over. A profile tolerance may be applied all over the three-dimensional profile of a part unless otherwise specified. If nothing is specified and only this symbol is given, automatically the control goes to the entire surfaces of the part, and it is a three-dimensional. So all 6 surfaces, if it is the component having, it controls it. It shall be applied in one of the following ways. So the first is the keeping a symbol. The symbol as it's shown here, it is a 2 concentric circles and it is kept on a leader line. The second way of the indication is that writing a text message, that means all over beneath the feature control frame. So this is a feature control frame, and in this feature control frame below the beneath a text written all over. That is also an alternative practice. And at the last the indication can be placed at the general tolerance block or the general notes. Normally this requirement comes near the drawing title block. There you can write the general values or the notes. Here is a little larger view to understand better about all over specifications. So since it is given 2 boundaries 0.6, then these are the 2 boundaries which are 0.6 apart, and these 2 boundaries are equally disposed from the 2 profile, and actual profile should be within the given 2 boundaries. Suppose it is not a requirement of all around or all over controlling of the surfaces, but different sections to be controlled with different tolerance zones. Then between 2 symbol is used. So between 2 symbol is these 2 arrow opposites. Then between 2 indicate that a profile tolerance applies to several contiguous features. Contiguous features you can see here is a small radius, then there is a the profile line from B to C like, and letters are used to designate where the profile tolerance begins and ends. So in case of this example, suppose profile tolerance is required 0.05 with respect to datum E and F, and it is applicable only to starting point C and D. These are the 2 letters. So C is the starting point here and D is this ending point. So from the C to D, the tolerance zone applicable is 0.05. Now let us understand, after applying the control of the profile, what about the conformance? Conformance in sense the profile, how it is to be accepted. So there is reporting the actual value against the given the specification value. The mathematical calculations are given in ASME Y14.5.1 2019 versions. So there was a lot discussion around in the industries how to produce the reports of the profile measurement. So this explanation would help you how exactly the output to be reported. When the report is given graphically, the conformance showing is very easy. It represents exactly how the profile is within the tolerance or not. For example, this is a true profile, nominal profile, and there are the tolerance zone, bilateral tolerance zone, which is here indicated as a T0, and here the upper tolerance is called MMB and the lower tolerance profile is called as LMB. It means least material boundary, and here it is called maximum material boundary. And the acceptance zone is when the actual profile lies between LMB and MMB, we can say the part is conform. So it is very easy, but it is little tricky to calculate the value against the given the tolerance T0. So that we would see in the next slide. For the conformance of the profile, there is one more term used, that is called actual zone. So nominal tolerance zone, we know nominal tolerance zone is a zone around a nominal profile, and these profile lines we called as maximum material boundary and least material boundary. And suppose this tolerance zone by the value it is shown as a T0, and here is a actual profile, and this is the point indicated here which is the farthest or at the larger distance from the nominal value, called here as a extreme point. If we draw a line, a profile line passing through this highest or extreme point and which is the parallel profile from the nominal, that is we call as a actual maximum material boundary. Similarly, exactly at the same distance, the distance which is this one is the highest extreme point. So at the opposite side in the same the equal distance, we created one more profile line, actual least material boundary. Please get informed, one important point here is the positive side, actual maximum material boundary is passing through this extreme point, but the extreme point at the lower side of the nominal profile is not touching to the actual least material boundary. So the concept here is when there is a extreme point either of the side, either positive side or at the negative side, that value is considered as a value to be placed on both the side to draw actual MMB and actual LMB. And this zone between the actual MMB and actual LMB is called a actual zone. Okay, and there are certain more parameters used called as the growth parameter. Now this is the maximum tolerance zone and this is a actual maximum material boundary. So this area or this distance is called as a growth parameter. The other side of the nominal profile is also a growth parameter. With this growth parameter and with the actual zone, how to calculate the actual value of the profile to show on the report against a given specification tolerance zone T0, that we are going to learn in the next slide. Now let us take a actual case for calculation of the actual value of a true profile. So here is a one drawing shown. This drawing shows profile control 0.4. It means this nominal profile or true profile is equally distributed as a bilateral tolerance, 0.2 on the positive side and 0.2 on the negative side. So taking some actual values in condition number 1 and condition number 2, how to calculate the actual values, let us discuss one by one. Now let us evaluate the given case. Here, against the nominal profile shown in the black colored line, the gray line of profile is a actual profile or measured profile, and the tolerance given is 0.4. So yellow lines we see here, these are the maximum material boundary and least material boundary. So this zone is called tolerance zone of a profile, equally distributed, that is, it is a bilateral tolerance, equally distributed, 0.2 above and 0.2 below, and gray profile line is a actual. When we follow the gray line, the actual line, we get an extreme point over here, and it is easily seen the actual point is little beyond the tolerance zone of the tolerance given. So it is beyond 0.2, and when from that point from 0.2 onwards, from the extreme point, when a profile parallel to the nominal profile is drawn, then the value between the tolerance limit maximum material boundary and the actual maximum material boundary, the difference shown here is as a G factor is equal to 0.055. So in this case, this 0.055 and the one side tolerance zone 0.2, when we add, that same is placed in the opposite direction. So as discussed in the previous slide, this maximum point is mirrored in the opposite direction, and from then one more actual least material boundary profile is created, and actual profile zone is now became 0.51 wide. So what is the conclusion here? The conclusion here is the tolerance given is 0.4. Against that, the actual tolerance coming is 0.51 wide. How it is calculated? It is calculated by measuring the highest point either of the side. It could be at the positive or negative. So taking the highest point from the mean line or the nominal profile, what is the value? That value is making double, just multiplying by 2. Then that value becomes a actual tolerance zone, and this is against 0.4 tolerance as a specifications. The measured value of the actual profile is 0.51. Hope that you liked this video. Please subscribe the channel and share it to others. For training inquiry, please find contact details.
Hello everyone, I am Shivani working in R&D BCI. So I have been come to GD&T from the past 3 days. So the session is very good. I got a more clarity on the basics of how exactly we'll go for giving the geometric dimensioning and as well as the tolerancing and what bases and all. So it brushed up all my engineering things from the start, so which made me, I think now I can feel very free and know how exactly we need to do that GD&T in my coming things. Thank you.